Good morning, good afternoon, good evening, everybody. My name is Vtt Approach. I'm the president of Saskatchewan Food Industry Development Center. Welcome to our Fermentation Webinar Series, Canada's Fermentation Ecosystem. Today, in the first section, we have three speakers. We'll be talking about the global fermentation ecosystem. Dr. Nesli Sözer from VTT. Dr. Nesli Sözer is a research professor at VTT. She'll be talking about the fermentation ecosystem in Finland with an EU perspective. In the second presentation, Dr. Dorit Rozner, Chief Technology Officer of the Kitchen Food Tech Hub in Israel. Dr. Rozner will be talking about the global viewpoint of the fermentation ecosystem in Israel. And our third speaker, Dr. Elaine Corbett, Director, Sector Innovation and Programs at Ontariogenomics. And Dr. Corbett will be talking about Ontariogenomics, Canada's $12.5 billion opportunity in food innovation. At the end of the webinar, we'll organize a Q&A panel. And in the next presentation, Ms. Muriel Garven with the Garven and Associates will be talking about mapping Canada's fermentation ecosystem. And at the end, we'll have a joint Q&A panel and a discussion about the entire Canada's fermentation ecosystem discussion. This webinar is basically sponsored by Protein Industries Canada, Saskatchewan Food Industry Development Center, Agwest Bio, Global Agri-Food Advancement Partnership, and as well as University of Saskatchewan College of Agriculture and Bioresources, the Department of Food, Agriculture, and Biosystems Sciences. So with that, I'd like to inform you that for all the questions you have, please go through the Q&A function in the Zoom system. You can ask your questions through the Zoom. And then at the end of the first session, we'll be going through all the questions through the Q&A panel. With that, I'd like to invite our first speaker, Dr. Nesli Sözer, to talk about the overall fermentation ecosystem in Finland with the EU perspective.
Good morning and good afternoon, everyone. Today I will give a brief overview on food fermentation ecosystem in Finland with an EU perspective. But before I move forward with my presentation, for those of you who are still not familiar with VTT, I have a basic introductory slide. VTT is a challenge-driven research, development, and innovation partner and one of the leading research organizations. Good morning and good afternoon, everyone. Today I will give a brief overview on food fermentation ecosystem in Finland with an EU perspective. But before I move forward with my presentation, for those of you who are still not familiar with VTT, I have a basic introductory slide. VTT is a challenge-driven research, development, and innovation partner and one of the leading research organizations in Europe. VTT has about 2,000 employees, of which roughly around 1/3 has either a PhD or a master's degree. Although we are based in Finland, almost half of our turnover is coming from abroad. There are many food innovation ecosystems and accelerators in Finland. The two large ecosystems are led by VTT. Food and Beyond is an ecosystem dedicated to help the domestic food industry through the research and innovation partnership and catalyze their success in international competition. Symbio Powerhouse is another ecosystem which includes diverse group of research organizations and companies currently actively working in synthetic biology. Besides these two large ecosystems, we have also different incubator programs and funds for boosting innovations, such as VTT Launchpad, Nordic Food Tech, which provides venture capital funding for startups, Founder Institute Finland for early stage startups, and EIT Food Fan, which is European Institute of Innovation and Technology Food Accelerator Network. EIT FAN is a European quite rich ecosystem of business research, business companies and research organizations that helps the companies move from an early stage to a global scale-up. We have also several funding bodies, such as Academy of Finland, which mainly provides funding for basic research. Business Finland, that focuses on providing funding to applied research and innovations, where both research organizations and companies can get access to this fund. There are also several specific programs which is mainly dedicated to food and provided by especially Ministry of Agriculture and Forestry. We have also ELU centers, which promotes regional development in diverse categories, including also food. Then we have CITRA, which is an independent, future-oriented funding agency that is influential both at national and international level. CITRA especially acts as a think tank, promoter of experiments and operating models, and a catalyst for cooperation. Besides traditional conventional fermentation, the fermentation ecosystem in Finland focuses both acellular and cellular products. As I mentioned earlier, the main ecosystem that connects different stakeholders in synthetic biology field is Symbio Powerhouse, where there are international large companies, mainly from materials, chemicals, and fuel sectors. However, with the latest research and innovation advancements in the field of cellular agriculture, now the ecosystem has several food-related young companies. And in Finland at the moment, there are 3 startup companies which are solely focusing on cellular agriculture in connection to food. And I can proudly say that they are all VTT spin-offs. These companies are supported both by Symbio Powerhouse and Food and Beyond ecosystems. Symbio Pilot is a recent initiative where we are just now applying roughly around €7 million funding from Business Finland. And the Symbio Pilot will enable the commercialization of new biomass valorization technologies by connecting stakeholders with synthetic biology background, thermochemical and mechanical fractionating background, and ICT expertise, as well as will bring on board investors in a jointly owned and jointly operated biorefinery pilot facility. Symbio Pilot will serve customers in their bioprocess scale-up phase that require high-quality aerated but also anaerobic fermentation, and will include also a variety of different downstream processing options. The facilities can be rented together with the operational staff, and it will also include fermenters both in food grade and non-food applications. Since this is still in application phase and also open for international companies, if there are any interest in joining Symbio Pilot, let's be in touch and we can discuss different options. In the end of this presentation, you will find my contact information, and we can continue the discussions if you have a willingness to join Symbio Pilot. The synthetic biology ecosystem in Finland is connected also to the European Science Forum and Research Infrastructure on Industrial Biotechnology and Innovation, which is called IBISPA. IBISPA is unique as it's a distributed European research infrastructure that is dedicated only for biotechnology. Currently, IBISPA gathers research facilities owned by various institutions and universities from 8 EU member countries, namely France, Spain, Italy, the Netherlands, Germany, Belgium, Greece, and Finland, but also UK. And the aim of IBISPA is to reduce the fragmentation and provide a comprehensive set of high-level research, development, and innovation services for industrial biotechnology players. Now that you have an overview of different food fermentation ecosystems and stakeholders, I would like to touch base to Vtt approach and the role of Vtt as an important partner within the fermentation ecosystem. As most of you know, fermentation is one of the oldest forms of food processing technologies, which has been originally used to preserve foods, but also design new flavors, textures, and boost the nutritional benefits of different food products. However, now fermentation is disrupting the food system by bringing in new food production approaches such as cellular agriculture. From conventional fermentation perspective, Vtt has a well-established culture collection operating since 1959, where there are more than 6,500 strains of different bacteria, yeast, and molds. We can measure, understand, and control microbes and their interactions within various food matrices, from drinkable products to spoonable products and to dairy and meat alternatives. We utilize conventional fermentation together with our enzyme know-how to modify the techno-functional properties, but also tailor the nutritional and sensory functionality of both ingredients and foods. Precision fermentation and cellular agriculture as a concept includes using single-cell organisms and bioreactors instead of animals and fields for food production. And the tradition for using single-cell organisms as food exists. If we look at microalgae such as spirulina, has long history as food. And corn, which is produced from Fusarium fungus, is widely available on the market. Cellular agriculture can be used to produce cellular products such as microbial biomass, cultured meat, and plant cells, and acellular products where highly functional and more pure protein, lipids, or bioactive compounds can be produced recombinantly. Finland also has a long history in production of single-cell organisms. Pekilo is the world's first commercial microprotein developed in Finland, and the development of the Pekilo process was initiated by the pulp and paper industry in Finland in 1960s, and their main aim was to add value to their side streams. The first Pekilo plant was completed in 1974 and had an annual production of roughly around 10 kilotons, which was sold mainly for feed applications in the Finnish market. The industrial operations of Pekilo continued for about 15 years until meeting an untimely end in 1991. Then the pulp industry had moved on with modern plants producing no suitable side streams for Pekilo production, and then the Pekilo fungus was deposited to our culture collection and has been hibernating under ultra-low temperatures at Vtt until the conditions turned favorable once more. We at Vtt created a new high-protein Pekilo, which can have about 65% protein, which is initially also targeted mainly for feed applications. However, now the spin-off company, Enifer Bio, is also tailoring a specific protein ingredient for food use by using Pekilo strain. We also have another spin-off company, which I would say in a more mature stage. Right now, they are building the factory. which will be operational in the end of next year. And the company's name is Solar Foods, where Solar Foods is producing microbial biomass for food by using gas fermentation and focusing on utilizing hydrogen oxidizing bacteria, Rhodococcus oporcus, that has the ability to produce an ingredient which contains 40 to 65% protein. Also, plant cells produce many of the same valuable molecules as whole plants have. They have been used earlier in pharmaceutical and cosmetic industries, but could we use them also for food? And here you can see some novel approaches that we have developed at VTT. The first one shows a food architecture design by using plant cells, Arctic bramble. And we have developed solid form structures that resembles a meat alternative, plant-based patty. And also we developed a process for production of coffee cells, and this has raised lots of interest recently because Finland is globally one of the most coffee consuming country. Trichoderma resin is a well-known industrial producer of cellulolytic and hemicellulolytic enzymes, but also recombinant proteins. It has a GRAS status, so generally recognized as safe for manufacture of food products. It is an efficient protein secretor where the highest protein contents that we have received at VTT has exceeded more than 110 grams per liter. And we have been successfully using the Trichoderma platform for expression of milk protein and egg protein, but also sweet tasting proteins. Ontariogenomics is another and quite recent VTT spin-off, which is focusing on production of functional egg white protein. Besides protein production, we have been also exploring the cellular agriculture concepts for microbial lipid production. Microbial lipid production is also not new. It has been used to produce some specific fats, for example, omega fatty acids at industrial level. However, microbial lipid production targeting certain meat lipids that give the unique flavor and taste without the animals is a new approach. We developed a fermentation process where microbial fats can be produced in a sustainable way from plant-based side streams by using safe microbes and today's modern biotechnology toolbox. There are many new business opportunities associated with cellular agriculture where both the society and environment can benefit. Innovation ecosystems enables to achieve excellence in research and business efficiently through cross-organizational networks. Therefore, it is essential to have both regional but also internationally connected ecosystems. Hereby, I would like to thank for your attention, and I would be glad to answer any questions you might have. Thanks.
Thank you. Thank you, Nesli. For our participants attending the webinar, just to let you know, we'll go through the Q&A at the end of the three speakers in the first session. So please save your questions and you can send them through the Q&A box. So I'd like to move into our next speaker, Dr. Dorit Rozner. Dorit is the CTO of the Kitchen Food Tech Hub in Israel, and Dr. Rozner will be talking about the global viewpoint of the fermentation ecosystem in Israel. Thank you.
Thank you, Mehmet, and thank you for inviting me here to speak with all of you. I'm the CTO of the Kitchen Hub, the first food tech hub established in Israel in 2014. In my background, I have a PhD in organic chemistry from the Weizmann Institute of Science, and I have more than 20 years experience in drug delivery, microencapsulation technologies, and fermentation of probiotics. Just a little bit about us. So the FoodTech, the incubator, the kitchen hub, is part of the Strauss Group. Strauss is the Israeli largest food company. It operates in 22 companies. We have annual revenues of about $2.5 billion. We are number 5 in the coffee globally and number 1 fresh dips and spreads around the world. Sabra from the US is one of our companies. The kitchen, we see ourselves as a company builders. We invest, we nurture, and we commercialize new companies. We have a partnership with the Israeli innovation authorities. Every company that enters the kitchen receives a budget of about $750,000 to start their initiative. 85% of the budget comes from the Israeli innovation authorities, and 15% comes from Strauss through equity. The time that the companies are working in the kitchen are about 18 to 24 months for a specific milestone that they have to achieve during the time that they are in the incubator. One of our venture creation model is using or licensing of academic research from the academia. We license the IP, we build a team, we invest in the seed round, and we launch a startup, hopefully a successful one. We give all the startups really a multi-tier support. In our kitchen, there are people from the technology field, like myself, business, and also HR and operation. And the startup receive from us full support in all of those factors. In the technology side, what we are doing is the due diligence for new companies. We are helping the startups look on their work programs, support them concerning IP and regulation. We are using also the help of the Strauss Group with their knowledge and expertise and pilots. In our global network, we have Givaudan, Mondelez, Danone, so they help the companies access to capital and also looking on the business-wise and help them accurate their products. So in what are we investing? Eventually, when we are investing, we are looking on a better industry and better food. So food tech across the whole value chain. If it's looking on healthy food, today we are looking on bringing the food that it will be more healthy, more sustainable, clean label. We are looking on the waste reduction, of course, safety and quality, and logistics. So all of those things are things that we are looking in new companies that enter the kitchen. Till now, we were evaluating more than 1,000 investment opportunities, and 23 of them entered our kitchen. We invested more than $200 million in our portfolio companies. 6 of them already built their own facilities, pilot facilities in Israel, and 9 of those 23 we created from licensing technology from the universities. So when we're talking about the future of food, the main question that we need to ask ourselves is how are we going to feed 10 billion people by 2050? And when we are thinking about it, we have to look on 3 major factors. One is the sustainability, of course. Today, animal ag is responsible for more than 14% of the greenhouse gas emissions. Efficiency, what are we looking into the efficiency? It's very easy to understand it if we think about that it takes 9 calories of food fed to a chicken to produce 1 calorie of meat. So no efficiency here, definitely. And regarding the safety, we are dealing a lot with antimicrobial resistance. We have a lot of heavy metals in our fish, and we have to find new, healthy, and sustainable solutions for that. In order to do that, the kitchen just now won a new tender for another 6 amazing years that we are going to face and work on deep tech, especially biotech, in order to fix the food system. So the companies that will enter the kitchen from when Kitchen 2 will start this year, we'll be dealing a lot in precision fermentation technology. We're going to use tools like synthetic biology. There is the first synthetic biology institute that established this year in Israel, and we are collaborating with him. One of the things that we will have to look into also is the downstream processes. So a lot of work on extraction and purification technologies, cell cultivation, of course, and all the enablers that we need in order to create those cell culture ingredients, if it's mediums, if it's working on scaffolding, if we're talking about the precision fermentation, about different strains, and of course, using also technologies of bioconversions like 3D printing, for instance. So when we are looking about the alternative protein landscape, and a lot of work is being done in this area with the Good Food Institute, also in Israel. So fermentation is definitely one of the emerging and critical platform for the alternative proteins. If we are looking on what's going on in the world, so global alternative protein investment grew by 60% from 2020 to 2021 and reached to a new really record-breaking about 5 billion. Israel is the second only to the US in investment and number of alternative protein startups. We are numbers 2 in the cultivated meat companies, about 12 companies already established in Israel. We are number 2 in the world in the number of fermentation companies, around 12, but this is only in the alternative protein. There are more in the area of different functional ingredients, such as natural colors and flavors. And we're number 1 in the world in the number of alternative seafood companies. Just this year, 5 companies emerged in this area. This is some of the companies that are working in Israel in different stages. If it's seed, then there are R&D that are more developed already, pilot scale and commercial. We see in the cultivated area, as I mentioned, a lot of companies that are dealing with seafood. In the fermentation space, we have a biomass fermentation like Mash Food, and we have other companies that are dealing with precision fermentation. They are in different stages. Remel just now announced for building their own pilot in Denmark. They are doing cowless milk. And NextFerm is already producing. NextFerm started with astaxanthin as the first product, and now they are working on proteins and selling. And in the plant-based, as you see, so many companies in different areas of using algae and using clean label ingredients in their products to create the new and sustainable proteins. When we are looking on innovation in the field of fermentation, really there is innovation in all the value chain. If it's starting from the feedstock optimization, so we're talking about any source of biomass that can serve for fermentation-based protein production. We're talking about, as I mentioned already, strain development, working on the bioprocessing itself, and also eventually on the end product, if it's a whole cell biomass, as mentioned before. And also if we're talking about a specific protein or other high-value ingredients produced by cells or microorganisms that can be isolated and purified. Just to summarize about the innovation that we see. So as I mentioned, strain engineering is very important. Downstream processes, it's a real bottleneck. Capacity is very low, and the processes are much suitable for the pharmaceutical industry than to the food grade industry. So a lot to be developed in those areas. Expanding the selection of the host strains, of course, and to find new substrates for those microorganisms that will be more sustainable and less expensive, much more cost effective. The target is the same. We would like to increase the titers and the yield of the target molecules and the protein biomass. Regarding the commercial readiness, so we have to remember that most of the capacities of fermentation plants were built 20 to 50 years ago. So the capacities are low. still lower than what we will expect in order to feed the world with proteins. And originally, we remember that they were all for producing APIs, amino acids, chemicals. So absolutely a lot of work is being done in the area of making plants that are food grade. As I mentioned, the limited downstream and a high capex. So eventually we would like to see new technology emerge in this field. And regarding the capacity, we will have a lack of fermentation plants in the near future. And this is something that we need to work on. Just to give you a point of view of pricing regarding alternative proteins. So small-scale fermenters of about 100,000 liters, the prices of the protein will reach to $150 per kilo. If we will compare it to soy protein, we are much behind. So we have to go to much higher scales in order to reduce the pricing or to be able to do a better expression of the proteins in the microorganism to reach numbers that are lower than $75 per kilo. And then we are talking about plants of more than 500,000 liters. Some of the examples of our portfolio company in this area. So we have mush foods that are using mycelium in order to produce ingredients for the meat alternative industry. They are doing hybrid products with meat and the mycelium and also plant-based only. And they are using biomass fermentation on a solid state in this matter. Imagine there is our precision fermentation company. What they are doing is healthy and sustainable nutrition on dairy proteins. They started with the whey protein, expression of the whey protein in fungi. And they have their own proprietary AI algorithm in order to increase the expression of the proteins in the microorganism. Another company we have is a MyProtein. They're already in the pilot scale, and they are producing in precision fermentation sweet proteins, sweets like sugar, and digest as a protein. In the cultivated meat area, we have 3 companies. The first that was established in Israel is Aleph Farm. It's also a technology we brought from the Techno, from the university, and they create meat cuts from bovine cells. Another company we licensed the technology is Wanda Fish. They are producing a tuna with a disruptive technology we licensed from Tufts University in the US. So also we do licensing of technology outside of Israel. And we have Foresee with a unique cultivated seafood platform, enabling dramatic cost reduction because in their technology, unique technology, they will not need any scaffolding and the amount of growth factors are really low in this technology, what enable us to create a more cost-effective product. Their first product in the platform will be eels. About the Kitchen Hub, and I can say general about the ecosystem in Israel. So the ecosystem in Israel is very active. They are promoting Israeli food tech in global events. We are working a lot in creating meetups with the Good Food Institute as well. We are supporting food tech programs. And just now we are building our first innovation center in our kitchen to support companies in the biotech and food applications. We have the special event every year, FoodTech IL. Unfortunately, the last years it was on Zoom, but we hope that this year in November we will all meet in Israel. This event is huge. There are people that are coming all around the world and a lot of startups are presenting. And this is our amazing team that we're all working together in all the fields that I mentioned. And you are welcome to look in our website to see the different portfolio companies that I could not put them on the screen and in this presentation. Thank you so much.
Thank you. Thank you very much, Dorit, for this wonderful presentation. With that one, for the questions, we'll go at the end. The next speaker is Dr. Elaine Corbett. And Elaine will be talking about Ontariogenomics, Canada's $12.5 billion opportunity in food innovation. Elaine, the floor is yours. Screen.
Okay, thank you. Can you hear me?
Thank you. Yes, we can hear
Okay,
you.
awesome. Okay, you can see the slides. All right. Okay, hi everyone. Thanks so much for the invitation today. To start off, I want to give you a brief overview of Ontariogenomics before telling you more about our work in the agriculture and food sector, and more specifically focusing on what we've been doing in the cellular agriculture space over the last several years. Okay, so Ontariogenomics is a non-for-profit organization leading the application of genomics and engineering biology-based solutions to drive economic growth, improve quality of life, and global leadership for Ontario. We work across three key economic sectors: agriculture and food, human health, and industrial biotech, and foster collaborative opportunities to collectively achieve our vision of healthy lives, a healthy economy, and a healthy planet through genomics innovations. So over the last 20 years, we've been funded federally through Genome Canada and also provincially through the Ministry of Colleges and Universities. Since our inception, there's been over 2.7 billion in raised and matching funds for omics research and innovation in Ontario, over 230 projects and 500 partnerships. This includes over 20,000 jobs, and currently we actually have over 319 million in active projects across the various sectors that we work in. So we do work both regionally within Ontario, but we also have some of our work has a national focus, and I'm just going to tell you a little bit about both of those. So we have a new strategic plan that you can see here at a high level. So we're working to build capacity and drive the ecosystem within Ontario, building public-private partnerships to help support startups and companies while augmenting IP and growing jobs in Ontario, training of talent that have the relevant and necessary expertise for the various sectors and businesses, and also engagement and education with various audiences to create awareness of the impact of genomics in everyday society. So we're always looking to the future and new opportunities for Ontario and for Canada, and have been working in the agriculture and food space for many years, funding a variety of projects across the sector and across the value chain. We've developed various strategic reports you see here, following extensive stakeholder consultation and partner funding programs connected to the recommendations from the report. So in 2018, we released an Ontario-focused genomic strategy on the agriculture and agri-food sector and partnered to develop a $3 million regional funding competition, ONRP3, that same year. And this resulted in 8 funded projects. This year, we actually partnered with others to develop high school lesson plans and videos focused on the successful projects as a way to engage the public, and specifically grades 7 to 12, on the interconnection between genomics research and the agriculture and food sector and the opportunities within that sector. And so in 2021, we developed a national report focused on cellular agriculture and a regional cellular agriculture competition, Accelerate On. Both were in partnership with others, and I'm going to tell you a little bit more about both of those today. So how do we get there? So for several years, Ontariogenomics has recognized the growing importance of engineering biology or synthetic biology, a platform technology based on the convergence of a number of different disciplines and applicable to many different industries, and has been driving the growth of the engineering biology community within Canada, including the formation of the National Engineering Biology Steering Committee. So in our 2020 Engineering Biology White Paper that you see here, we identified 3 business verticals that Canada can capitalize on in this space: by manufacturing of advanced health technologies, food security, including cellular agriculture through the biomanufacturing of protein ingredients and other food products, and low carbon biomanufacturing of food products as we move towards a net zero carbon economy. So in 2020, the McKinsey report indicated that advances in biological solutions, which they termed the biorevolution, will create $4 trillion in value in the next decade or two, and that up to 60% of the global inputs to the economy can be made biologically. Greater than 50% of these will come outside of human health, with 36% in agriculture, aquaculture, and food, and with alternative proteins that include cultivated meat, plant-based, and synthetic proteins worth 40 to 120 billion annually. So this has been decades in the making, but it's happening now because of a step change in our ability to understand and engineer biology. It's enabling us to produce products in a different way. In 2021, the Boston Consulting Group and Blue Horizon estimated that the alternative protein space, again including plant, microorganism, and animal cell-based products, will reach at least 290 billion per year by 2035. So what's included in cellular agriculture? So cellular agriculture is another way to produce food using techniques we've used for decades for other applications. It covers the biomanufacturing of products through precision fermentation, whereby cells such as bacteria, yeast, algae, or even plant cells can be turned into miniature biological factories and used to produce a desired product in brew-style tanks, similar to how we brew beer, wine, or make kombucha. This could be a more complete product, such as egg white protein or honey, or ingredients such as flavorings and pigments. It also includes tissue engineering and cell culture, in which cells from animals, fish, or other seafood are grown outside the body in bioreactors to produce cultivated meat or seafood products. So these are just some examples of products that are in development, in some cases on the market, and you heard about these already, or some of these today. Again, there's been a multi-generational development of this technology, with precision fermentation-based rennet in cheese making being produced since the 1990s, dairy protein in products such as ice cream and cream cheese, heme protein in the Impossible Burger, and plant-based products such as chocolate and coffee. You might have even tried the Impossible Burger, which is widely available in Canada, and you may have heard of Perfect Day, where the Canadian Pension Plan Investment Board were lead investor in their Series C raise and co-led their Series D of $350 million. So mycelium, you see in the center, is an example of biomass fermentation and can also be grown in bioreactors to create bacon or steak fillet or other products. Focusing on the right, you see hybrid chicken bites made of cultivated chicken and plant-based ingredients are available in Singapore, while people are working in other products such as beef, fish, and foie gras. So why are we so excited about the space? Well, the types of products that can be produced is limitless. And with over 9.7 billion invested in the space when we calculated late last year, there's an immense economic opportunity developing. And we want to help ensure that Canada and Ontario is an exporter of these products and not just an importer of what other current leading countries are making. So the Canadian cell ag landscape is actually rapidly evolving and shows tremendous promise. Canadian startups are already taking advantage of the growing business-to-business and business-to-consumer opportunities to produce a wide variety of products. And there are currently 17 and growing cell ag companies in Canada that we are aware of. And we're very excited to have 10 of those companies in Ontario. To give you an example of just a few of these companies across Canada and what they're doing, Future Fields are making growth factors for the cell ag market. Whitebird Foods are focusing on scaffolding for plant-based meat, cultivated meat, or alternative proteins. Live proteins are using precision fermentation to develop protein ingredients to improve taste, texture, and cooking experience in plant-based food formulations. Mara Renewables are creating omega-3 fatty acids from algae, while Apalia are making whole milk with mammary cells. So following on from our 2020 white paper, we decided to take a deeper look at the food security business vertical that focused on cellular agriculture, recognizing the complementary opportunity presents to a strong agriculture and food sector in Canada. Last year, from the National Engineering Biology Steering Committee, whom you see here, and who our CEO is chair, we formed the Food Security Subcommittee, consisting of 3 members of the National Committee: Isha Datar from New Harvest, Vince Martin from Concordia University, and Stephen Webb from the Global Institute for Food Security, along with Alison Sundstrom from Builders BC, to help provide guidance as we took a more focused look at the space. Working with Agriculture and Agri-Food Canada and Lenore Newman and her team at the University of the Fraser Valley, we conducted a series of interviews and focus groups over several months with over 65 Canadian and international expert stakeholders to identify and refine a list of benefits, challenges, key actions, and priorities for an emerging cellular agriculture industry in Canada. We also engaged with economist Mike Palmassa from the University of Guelph, who we worked closely with to build and refine the economic case for cellular agriculture in Canada that had a food innovation focus. So we were accepted to the Canadian Science Policy Conference and took the opportunity to launch the CELAG report there last November. We had Deputy Minister John Kelly from Amafra moderate the panel, along with our CEO, Bettina, Juliana Toulouse from AAFC, Alison Sundstrom from Builders BC, and Lavanya Nandan from Merck KGaA. We discussed the outcomes from the report and next steps for Canada. So the economic analysis in our report indicated that cellular agriculture could be worth $7.5 billion a year and up to 86,000 jobs by 2030, and up to $12.5 billion a year and over 140,000 jobs for Canada in the future. And we identified 3 actions that need to be taken for these benefits to come about. So the first is develop a national vision and strategy for Canadian cellular agriculture industry in the near term and have a collaborative plan for creating a strong industry across the country. This is foundational to enable a growing domestic ecosystem and fully realize the benefits presented by this industry. An outcomes-driven national vision and strategy should be developed collaboratively, be inclusive of stakeholder requirements, and include a clear plan for implementation in the short, medium, and long term. The second is establish a clear and transparent regulatory framework for cellular agriculture products in Canada. So Canada is encouraged to proactively develop an agile, iterative, and innovative regulatory framework by building on existing processes to support the evaluation and approval of cellular agriculture products in a timely manner, and in alignment with Canada's current rigorous regulatory process and excellent food safety standards. This would ensure that producers and manufacturers understand the pipeline and consumers have confidence that the products are safe. And finally, provide supporting mechanisms for research and commercial development so that we have capacity from research through to scaling. And this will be critical for a thriving domestic cellular agriculture industry. So taking a deeper look at the third actionable opportunity, which is most relevant for the discussion today, to support research, early government investment and incentivization would catalyze invention, help de-risk opportunities, and attract private sector investment, while also incentivizing innovation and driving company creation and entrepreneurship within Canada. Funding could support a variety of things, from both fundamental to industry-driven research, open science. It could align with strategic government focus areas or grand challenges, focus on key areas of multi, cross, and transdisciplinary research for advancing cellular agriculture technologies, and that are also applicable to other business verticals, and should also include social sciences. To support commercial development, early startups require support in the form of lab space, facilities, and infrastructure in the form of innovation hubs, accelerators, and incubators, which would also include access to expertise, mentorship, and investment opportunities, including public and private seed funding for initial company growth. While Canada has some capacity, a lack of facilities for scale-up is viewed as the most significant bottleneck globally, and is a primary reason for companies to leave Canada for other jurisdictions. The initial outlay to establish domestic scale-up capacity in localized ecosystems would be high, but a fee-for-service operations could provide a global leadership opportunity for Canada with potential to attract foreign companies. Supporting applied research and commercial development through public-private partnerships could also help bridge some of the gaps between research and translation, provide access to infrastructure, and create linkages and entry routes into the supply chain for B2B companies. So to accelerate production scale-up, some satellite companies are forming strategic partnerships with large food corporates, including Perfect Day in the US, partnering with ADM, and Delter partnering with Switzerland-based Lonza Specialty Ingredients. So momentum in cellular agriculture is advancing globally. However, the window of opportunity is rapidly closing. This is a developing sector in Canada with a wealth of domestic expertise, a strong agriculture and food sector, and access to export markets. Now is the time for Canada to act to maintain competitiveness, diversify its food and agriculture sector, meet sustainability, food security, and resiliency goals, and capitalize on this considerable economic opportunity and growing cellular agriculture industry worldwide. So keeping momentum going on the cellular agriculture space in Ontario, we developed a partnership with the Canadian Food Innovation Network, or CFIN, and just a week after the CalAg report's release, we launched a joint funding competition, Accelerate On Food Innovation with Cellular Agriculture. So previously, a small number of cellular agriculture projects had been funded across the country, but this was the first dedicated cellular agriculture funding program within Canada. The competition was open to startups, SMEs, and academics within Ontario using cellular agriculture innovation applied to the food and beverage industry. Had to be enabled or have a component of genomics or engineering biology within the projects, and produce benefit to Ontario's cellular agriculture and food and beverage ecosystem. So we received a lot of applications, and with an external expert committee, 4 projects were chosen to be funded that were announced in early May. So we have Ardra developing fermentation-based production of heme as a natural flavor ingredient. CalAg Tech is manufacturing fish muscle stem cells from 2D to 3D culture system with their partner CCRM, which is the Center of Commercialization of Regenerative Medicine, to scale up its cell manufacturing process. CCRM is a global leader in scaling up cell manufacturing in the health sector and is a great example of strategic partnerships to accelerate scale up and opportunities to work with expertise in other sectors to help advance this space. We also have Evolved, which is previously called Karo Meats, creating cultivated pork belly that is identical to conventional pork belly, and Michael Garten, an academic from the University of Toronto, working in collaboration with the company Microbial, establishing foundational tools for cultivated pork production. So I just want to say thanks so much for your time. I'm happy to answer any questions you may have and connect afterwards with anyone who is interested.
Thank you, Elaine. Thanks so much for the wonderful presentation. Now, with that, I'd like to go for the last 6-7 minutes until 11 with our Q&A panel. I'd like to invite our panelists into the program. I see Nesli, Dorit, and Elaine. So I'd like to start with especially some of this whole wonderful growth and everything is happening all around the world. What do you see the challenges for the growth and the bottleneck, potential threats for the growth in the next 5 to 10 years? Like, are you doing any actions or anything preventative to work on that proactively? I'd like to start with Nesli and go to Dorit and Elaine. Like in this whole space, in the cellular agriculture, bioengineering, what are the overall challenges you see and potential bottlenecks that we may encounter in this whole journey that we're all going through? Nesli, we'll start with you. Okay.
Mehmet, the line was breaking up a little bit, but I believe I got the essentials of your question. So what are the bottlenecks and challenges related to cellular agriculture? If I respond from the EU perspective, obviously the legislations is the sometimes it's the game stopper or game slower. Of course, genetic modification, the approach towards genetic modification is very different and very strict in innovations, or I must say 95% of these innovations related to cellular agriculture needs to go through novel foods legislation, which is at minimum a 3 years process. So these are the challenges when it comes to cellular agriculture, and often the consumer and how the consumer will perceive this new way of biotechnical food production is still a bottleneck that we have to all come over.
Okay. Thank you, Nesli. I know you're in a little bit low bandwidth area, so thank you so much joining us in the session. Dorit, would you like to comment?
Well, yes, I think I also mentioned it. I think that the main issues will be the facilities, food-grade facilities for all the new initiative in the field of fermentation and cultivated meat area. And I think that one of the major issues, at least in Israel, that we need to create professionals in this area of extraction and separation processes, downstream processes, fermentation in Israel, in the food. So a lot of work is being done in this field to create new professionals.
Thank you, Dorit. Elaine, would you like to comment?
Yeah, I think it's very similar to what Dorit and Nesli said. I think it's funding for startups to help support them, but also facilities to enable their growth, but also scale up from the whole way from in the lab testing to product to commercialization. I think regulatory too is also very important, which I mentioned earlier on. But yeah, the HQP is very important as well. I think a lot of those working in the space right now have expertise in other sectors, from the health sector, industrial biotech, and so forth. But they need to work closely, and they do work closely with the food and ag sector. But I think it's creating awareness of those HQP and having more HQP that will feed into this sector. And consumer engagement is super important as well. Not everyone knows these products are being developed, and it's critical to have that engagement and education as technology develops before as these products come to market.
And don't forget about the regulation, that it's a challenge by itself, definitely.
Thank you. Going back to the regulations, like what we experienced with the GMO technology over the last 30, 40 years, as much as we became successful in the industry in so many fronts, there are still several countries and certain areas that people are still looking at quite skeptical to the GMO technology and the GMO crops. So in terms of all this labeling, the status of these products, how they can be marketed to the consumers, what do we need to do at the consumer level? Like, what are the strategies that you can talk about, like at this stage, especially we are now in the process of growing, what do we need to do with the consumer so that we can tell this story, so that we'll basically get their buy-in and their acceptance early so that we can put a much better growth trajectory in the cellular agriculture and the bioengineered products. Nesli, would you like to comment on that?
Yeah, so actually that's a very good question, and I think the way that we respond when we are presenting, for example, recombinant production of egg white protein, where we have a recent startup, they ask, how does it taste? I mean, then our response is, okay, it tastes the same as egg white. So I think from the consumer end, they are really thinking that, and a typical question is, are you feeding antibiotics? What kind of, facial media are you using? Is there something that is not good for me? I said, okay, all these things that we are doing is to make the production also more clean, so to avoid the antibiotics and all sorts of problems that's associated with today's agriculture, not to mention all these sustainability issues. So yeah, we have to communicate wisely with the consumers. They have this very, strict barrier. Even with processing, when it comes to processing, there is a huge debate between minimal processing and highly processing foods, and classification of food based on their processing. And I think there will be also a panel at the IFT discussing about, are we going to eat processed foods and so on and so forth. Yeah. Consumer part is really very important, and we have to engage them to this process. In the end, all these products will be a consumer product, and they have to be approved by them.
Thank you. Dorit, what would you be?
Look in this. Well, first of all, the regulation will be a process. If we're looking on the US and also in Israel, so it's definitely part of the novel food. And we will eventually, in the recombinant proteins, we will need to show that the protein is clean from DNA and that the functionality is the same as in the natural ingredient. And eventually to the consumer, they will need, like Nesli was mentioning, it has to taste like and feel like the real thing. And there where we are going with, if it's with different enablers to add to the products, with the recombinant proteins. And I guess that from my point of view, I guess that the first products will be hybrid products. And this will create some kind of a learning process for the consumer to meet those new ingredients.
Elaine, do you have any comments?
Yeah, I think I agree with everything that was already said. I think, like, there will be some, maybe, not all these products will be, genetically modified. A large proportion won't be. I think transparent labeling will be important so that the consumers have choice. I agree, the benefits should be articulated to the consumers. Like, these are products that can be tailored to suit like health goals or restrictions that they have in their diet. And communicate, I think, in language that's understandable. Like, we're using these tools and technologies, similar things to make beer, wine, cheese, all these things you love, we're already using these for. So I think it has to be, but engagement is definitely important. And it has to taste good, really. If it doesn't taste good, and we have to get to the point, initially it might be they're more high-end products as they come out, but as we reach more scale, they'll be produced, at a similar cost than current products. And I think, it'll be open to all different consumers to try and enjoy.
One last question before we go to Muriel's presentation is about the circular utilization economy in terms of the food waste. I'd like to start with Dorit on this. Dorit, like, with the overall raw material and the substrates that all these products can be utilized, is there an effort on the overall food waste? How the overall food waste can be utilized, and the fermentation, bioengineering, cellular agriculture, whatever the process we apply, can be overall be utilized as part of this whole circular economy, more with the urban populations in the cities, more like a fermentation systems in the cities. Can you please talk about that, just to share your thoughts?
So definitely there are a lot of activities in this area, and still there are a lot of open questions. One of the questions, what are we going to do with all this biomass that produced after the fermentation? we will create so much proteins, and we will have huge amount of GMO biomass that we'll have to handle. So today, a lot of companies are talking about feed. They will all give it to feed, but we need to be much more creative in this area. We will see a lot of work in the media, if we will be able to upcycle the media and to use the same ingredients, to use the downstream processes like using yeast extract and extract protein from it, from the breweries, for instance. So a lot of work on the downstream processes, and also the utilization of different ingredients in the medium to do a better upcycling of the product. This is what I see in those main areas.
Nesli, Elaine, would you like to comment on that?
Yeah, sure. I think there's lots of opportunity. We have a lot of feedstock in Canada. We have a lot of byproducts that can be utilized for something else. With synthetic and engineering biology, we have the ability to customize microbes that can, break down these different feedstocks into different, products that would be needed for the media for different products that we produce. Provides an opportunity for valorization of byproducts, alternative revenues for current producers, as well as the ability to, grow customized feedstock for different products that will be made. So I think there's a lot of opportunities, just deciding what's the right opportunities to do first.
Thank you.
Yeah, maybe I would like to also bring up the point, techno-economical feasibility issues. So those are very much connected to the feedstock that you are using and then the downstream processing. So besides the side stream valorization, waste stream valorization, we have to also pay attention what kind of pre-treatments are needed to make them workable during the cellular agriculture process. So that's also an important input for the techno-economics and feasibility of the whole process.
Thank you. Thank you, everybody, again, for joining the panel, for your wonderful presentations and your feedback into the questions. There will be a couple other questions that we'll be addressing those in the final Q&A panel at the end of the full webinar. So with that, I'd like to move forward with our next presenter, Ms. Muriel Garven, with Garven and Associates. And Muriel will be talking about our findings as part of our project on the Canada's fermentation ecosystem. And Muriel will be talking about our research findings, our surveys about what's the overall Canada's fermentation ecosystem looks like at the moment. And there will be other questions to be followed up at the end of Muriel's presentation. Muriel, the screen is yours. Thank you.
Good morning. My name is Muriel Garven. I'm happy to be having an opportunity to present a project that Garven and Associates has been doing with the Saskatchewan Food Centre on the mapping of Canada's fermentation ecosystem. Just a little bit about Garven and Associates as a background. We're a national management consulting firm with a 30-year history. Our two principal consultants, myself and my partner, Stuart Garven, have completed over 250 consulting assignments, most of which have been in the agriculture and food sectors across Canada. So as a result, we've had an opportunity to work with the Saskatchewan Food Centre on several projects over the past number of years, giving us a very good knowledge of the centre's strengths, the services that it offers, and the priorities that it has moving forward. We have a very good understanding of where the centre has been in the past and a good knowledge of what it wants to do in the future. Just going back and indicating how this project came to be. In November of 2021, a partnership to advance fermentation processing in Western Canada was announced, with seed funding from Protein Industries Canada, and the following partner commitments, both financially and in-kind contributions of time and expertise. We have a $1.3 million project to advance the fermentation ecosystem in Canada. What Garven and Associates is doing is really a project within a project. our job is to help this consortium to better understand the fermentation ecosystem in Canada by mapping the companies, the research agencies, and the funding agencies that are involved in Canadian fermentation. We've identified fermentation participants in a number of different subcategories. We looked at those individual agencies and institutions that are involved in research. Some of those are academic and some of those are public sector research initiatives. We looked at funding agencies that are prioritizing plant-based proteins and have made contributions and have funded projects that have to do with fermentation. And then we looked for private sector companies that are involved in doing all sorts of different kinds of initiatives that utilize fermentation in their projects. They will be using traditional fermentation, biomass fermentation, and precision fermentation. And we also then looked to find educational institutions that offer specialized training initiatives in the fermentation sector. So the process that we used, our methodology to come up with the individuals, companies, and the individual agencies and institutions that we've incorporated into the map, it has been to throw out a broad net to try and capture as many agencies as we could by looking at a number of different groups. And we had to then take about 150 contacts and narrow those contacts down into who really fits into our ecosystem as participants. So really the primary filter, if you like, to narrow that number down was to ensure that all of the agencies and private sector companies had Canadian locations and were involved in Canadian production activities. We also looked for companies and agencies that use traditional biomass or precision fermentation technologies. We have several companies that are in the plant-based protein industry, but do not use fermentation. So those particular companies did not fit within our ecosystem. And we also wanted to make sure that the companies that we chose and the institutions were focused on plant-based protein ingredients, flavors, and the production of bioproducts. So after using this funnel, if you like, or filtration system, we were able to take some 150 to 175 contacts and narrow that down to a much smaller number that we were able to put into our ecosystem map. So we used some sort of broad definitions, if you like, to come up with who fit in each of these categories. The research agencies and institutions involved in the support of traditional biomass or precision fermentation, one of those three, with a focus on the food and agriculture sector, were chosen for inclusion in the map. There are many agencies that do biomedical, pharmaceutical, and cosmeceutical research using fermentation, but we didn't include those in the map because we were focused on agriculture and food. The funding agencies that we incorporated into the map are a small number because they are primarily focused and have the strongest interest in the advancement of plant-based protein, and also work in the food and agriculture sector. So although there are lots of funding agencies who have funded fermentation companies or fermentation initiatives, we only chose those companies that focused on those particular areas. And so that's a much smaller number. Private sector companies, we were able to find over 50 private sector companies across Canada that use fermentation as a tool to produce alternative plant-based proteins, ingredients, flavors, and bioproducts. At the same time, we narrowed that focus as well. We did not incorporate the companies that use fermentation for wine, beer, and kombucha, very traditional fermentation technologies, cultured dairy products and vegetables, like pickles and so on, and we did not incorporate fermented meats in the ecosystem map. We were really looking for the companies that were using unique ingredients and also were using biomass and precision fermentation primarily. So those were the areas that we were focused on. So if we just look at the research institutions and agencies that were included in our ecosystem map, there are research agencies at both the national level, that would include the National Research Council and Agriculture Canada. And then there are several research agencies and institutions who primarily focus on provincial target audiences, but also have client bases that might go outside of their traditional provincial borders. So just some examples of those types of companies are Inotech Alberta, Biozone Ontario, Biofood Tech in Prince Edward Island, and of course the Saskatchewan Food Industry Development Center located in Saskatchewan, in Saskatoon. Again, just going back to the funding agencies that I indicated, we narrowed the focus down to only 3 funding agencies whose primary focus is on plant-based protein. And that was and also focusing on agriculture and food. So we looked at Protein Industries Canada. That's one of 5 Canadian superclusters that is focused on protein and high quality plant-based products and co-products. We also incorporated Cult Food Science, who is that is a investment company based, headquartered in British Columbia, in Vancouver. They invest in early stage initiatives in cultured meat and dairy, cell-based foods, and obviously fermentation. So they have a variety of different investments, well over 20 significant investments all over the world, as well as invested in 3 Canadian-based companies, Opalia, which is a company that produces milk, Fiction Foods, which is working on egg replacement, and Cell Ag Tech, which is a cell ag company. And the third funding agency we looked at was New Harvest Canada. There is a New Harvest International headquartered in the United States. New Harvest is a not-for-profit, donor-based agency that focuses on providing funding to researchers who are focused on meat and cell-based agriculture, cultured meat, pardon me, and cell-based agriculture. And many of those individuals use fermentation in their research projects. And then the private sector companies, as I said, we got over 50 private sector companies that we identified in Canada that use fermentation as a tool to produce their products and their flavors and their ingredients and so on. We looked at these companies in 5 different areas. Contract fermenters, who are companies that provide fermentation services to other companies to accomplish their goals. Companies that are involved in feedstock and microbial strains and cultures development. Ingredient producers, commercial product sales people, individuals who are actually producing products for the consumer, and industrial and non-food processors who are using agricultural biomass as a base. So we were able to connect them back to the agricultural sector. And so they were also included in the map that we prepared. I just wanted to give an example of some of the types of companies that we were able to put into each of those classifications. And I just wanted to, these are just examples because, as I said, we have over 50. In the contract fermenter category, we have BioVectra that works out of Prince Edward Island and Nova Scotia, a very large contract fermenter. Proventus Bioscience, which is a biomass contractor that works out of Brampton, Phyton Biotech, which works in British Columbia, and Sabinsa has a small fermentation contract operation in Canada and a much larger contract fermentation operation in the United States. In the feedstock microbial strains, some examples of companies that work in that area, Biana, which is a company that works with lactic cultures. Lalamand is in the yeast and bacteria business. Caldwell Bio is also involved in vegetable cultures and starters. And Mara Food Group, which is involved in enzymes and so on. Ingredient producers are, there are many different companies in Canada that are producing ingredients for others to utilize in their particular initiatives. And this often is high value products that are produced through a fermentation process. They don't necessarily produce a huge quantity, but the products that they produce are worth a lot of money. So these are some examples. Ardra Bio, which produces leaf aldehyde. Bartek, which is in the malic acid business. Biofect, a relatively new start company that works with heme, and Brazian, which is a sweetener, and Algorithm, which is a company in Saskatchewan that produces enzymes from algae. And commercial product sales, here's some examples of companies that are producing products that are meant to go directly to the consumer. Company in Prince Edward Island by the name of Small Food, producing food ingredients and so on that they sell to others, and they're also in the business of producing a fish burger patty that will be available commercially. Willow Bioscience is a cannabinoid company in British Columbia. Unite is an affiliate of Noble, which is a company in Peterborough, Ontario, and they produce egg replacements. And Cultured is an example of a relatively large cheese manufacturing company that produces their cheese from nuts and other products like millet and so on. And we have a number of cheese producing companies that are using fermentation to produce unique products for the consumer in the ecosystem map. And a couple of examples of companies that are producing industrial products, specifically bioplastics, Terra Verde, which is located in Edmonton, and Genexus, which is located in Scarborough. So then we took all of these agencies and institutions in the research business and in the funding area and these private sector companies, and we used Google Maps to place them on a map of Canada so that you could identify exactly where these companies are located. We used 3 different colors to identify whether the dot on the map was a private sector company, whether it was a funding agency, or whether it was a research institution. This particular snapshot here just shows you the private sector companies that are located in Ontario and Quebec, where many private sector companies in the fermentation sector are located. But the map that you can access by going to the Food Center's website, you'll be able to find the link that will let you utilize this map and see what companies there are all across Canada and the research institutions across Canada as well. So you'll be able to, after this webinar has been completed, you'll be able to get that information from the Saskatchewan Food Industry Development Center. Then once you click on one of the dots, up comes some tombstone kinds of information about the particular company so that you can see what first of all, what kind of a product the company produces, where they're located, their address, the individual senior manager's contact information and phone number, and an email. For most of the companies we have on the map, we are able to provide all of that information. For some companies, it's a little more difficult to find, and so we have partial information. And as time goes on, we will be able to make changes and adaptations to this map. The whole process will require that going forward, that this map is constantly revisited, because companies come and go. Many of these companies have been purchased by other companies and so on, and some companies don't survive. And so this will constantly have to be updated, probably on at least an annual, maybe a semi-annual basis, in order to make sure that we're providing up-to-date information. We did not put the educational institutions on the map at this point in time. We find that the educational institutions have a variety of different courses and programs and so on that are somewhat not always offered every year. Not all the classes are offered every year, so it's difficult to identify specifically whether or not they're providing training in fermentation. So what we've done in our report is that we've listed all of the educational institutions across Canada that we identified programs in, and we've listed those programs, and they're in the report that is also available through the Food Center. What we found is that the universities and private sector companies reported that they were able to do basic introductory level training programs, and it was much more difficult for them to provide the more advanced fermentation programs, because they didn't necessarily have the technology within the university facilities or within the training facilities in order to provide hands-on programs and services, so that the individuals could really develop specific expertise. So there are just a smaller number, a small handful of universities who are providing enough training for fermentation scientists to be graduated out of those institutions. We also found that individual companies are somewhat unaware of the kinds of training programs that are available, so they're not very familiar with where they can send their own staff in order to upgrade their skills and to learn more in the fermentation area. So there's value in providing a registry, if you like, of educational institutions that are providing fermentation programming. One of the benefits of I'll just go through this slide very quickly. That's just the list of some of the universities. But one of the benefits of the research that we did was we were able to then have a large number of contacts, both in the research area and also in the private companies. And what we thought would be a good idea, because we had these contacts, would be to invite them to participate in an interview program with us, so that we could learn more about their goals, their objectives, the kinds of projects that they're involved with, and what some of their barriers and challenges are in terms of growth and development. And through the interview program, we were able to talk to individuals who were able to provide opinion on very specific opinions on what some of the key developmental gaps and barriers are for fermentation companies in Canada. And I just want to take a couple of minutes. Some of these barriers you've already heard from other speakers in the webinar, but I'll just review them quickly, and what we learned through the interview program that we were involved with. First of all, the number one concern for most companies and for research, for those research institutions that are working with companies, they identified that the limited access to funding was a significant challenge for companies to get started and also to grow. So the venture capital that's available for startups is somewhat limited, and that growth capital is also a challenge for many companies once they have got a product or a project undergoing the research that they want to do. They have some difficulty finding the funding to maintain it. Some individuals indicated that funding in Canada in particular requires several funding rounds of application, reporting, and so on. And this is very time consuming and slows down the development process. And that leads into the whole concept of how to manage the regulations and so on. And that the complexity, the time, and the cost of achieving regulatory requirements can be an issue and a barrier to growth and development for many companies. Clearly, one of the major challenges for Canadian companies is accessing the infrastructure they need to be able to grow their companies and to do the research and development that is required. And that is specifically challenging for those companies that are in the food sector, because there are some large fermentation facilities available in pharmaceuticals and in the health industry, and those facilities are not available to food grade companies. And so accessing food grade CFIA approved infrastructure is a major challenge. Companies need to, once they have a good idea and they know they have they've got a proof of concept in place, they want to be able to scale up, and the capacity to do that is limited in Canada in particular. And every company is unique and has their own unique program of research, and they have their own unique outputs and products. And so that requires a whole range of downstream equipment and technologies. Most fermentation contractors and research agencies are challenged to be able to provide all the range of downstream equipment that companies require in order to be able to move forward. Access to qualified and knowledgeable human resources with hands-on fermentation skills are very limited, and being able to hire the right talent is a major challenge and a barrier for many companies moving forward. We asked several companies if they thought there would be any advantage to having an association of fermentation industry participants, and they were very keen to pursue that idea, because they don't have very many opportunities to talk to others who are using fermentation in their business. They would like to be able to share ideas, talk about opportunities that might be available, how some companies have overcome challenges and barriers and so on. And so there is some interest in the concept of having an association to support the companies that are involved in fermentation in Canada. Several of the companies that we spoke to said that it's important that fermentation skills and abilities be developed in all three of the all three of the fermentation types: the traditional, the biomass, and the precision, because there are opportunities for growth in all three areas. And there are getting to be a growing number of companies within the fermentation space in Canada, making the access to the limitations of human resources we have even more challenging, the access to scale-up facilities and technical facilities more challenging, and it's more difficult to find investors to invest in new initiatives. So this cluster of companies that is getting involved in fermentation as an opportunity is getting to be large, and that in and of itself can be a barrier to the development for those that are already in the industry. So just in summary, I just wanted to summarize some of the key takeaways from this particular project. We're excited, and we were very surprised to find as many companies that we did find that are actively involved in the fermentation space. The use of biomass and precision fermentation in the food industry is relatively new, and it's grown rapidly in the last 5 years, in particular, 10 years in general. But what we do know is that the infrastructure to support this rapid growth is lagging somewhat behind. There is no one-size-fits-all approach to research and development. The size of the fermentation equipment required depends directly on the type of biomass that's being utilized and the output products that are being created. For some companies, the bioreactors to produce the product they want to produce have to be fairly large. For other companies that might be producing a very small flavor or ingredient, their need for bioreactor space may be very small in order to produce the amount of product that they need in order to make a viable company work. So this poses unique challenges because service suppliers have to have technologies and infrastructure that cover a wide range of company needs, and they also have to have significant downstream equipment in order to be able to advance company requirements. A significant percentage of fermentation infrastructure in Canada, we know, is devoted to high value pharmaceutical, health, and cosmeceutical outputs. These facilities don't have the potential to cross over and work in the food sector because of the cost associated with retrofitting the equipment, maintaining the equipment, and cleaning it in between the production runs. And so those companies that are focused on pharmaceuticals stay in that area, and they do not make themselves available to the food sector. So we need very specific food sector and food quality infrastructure and fermentation facilities to be able to really rapidly move forward. And that just, the next point is exactly what I was just saying. We need food grade and food standard production facilities. And this just puts a star beside what the food center is doing in its expansion plans to raise their capacity in fermentation to support companies in the West, but also to support companies all across Canada. We also know that there's a general lack of qualified human resources, and specifically with human resources that have practical food fermentation training, hands-on kinds of experiences. In particular, fermentation scientists with knowledge of the food industry are in short supply. There are fermentation scientists with broad knowledge of fermentation, but they oftentimes do not end up working in the food sector. And so we know we have a large demand for fermentation scientists in the food industry. And we need to attract more individuals to go into that area. The fermentation ecosystem in Canada is growing rapidly, even though there are gaps in service and development barriers to overcome. This project that PIC and the other collaborating agencies are involved with this is a very timely project, and it's been very interesting for Garven and Associates and for myself and Stuart to be involved in this research. We really appreciated the opportunity to learn and to have an opportunity to talk to so many exciting and forward-looking companies. Thank you very much.
Thank you very much, Muriel. Thank you for the presentation. And then now I would like to invite all our panelists. Mr. Jay Robinson, the CEO of GAP, Global Agri Advancement Partnership, Dr. Elaine Corbett from University of Saskatchewan, Dr. Karen Churchill, President and CEO of Agwest Bio, Ms. Megan Garvey, CTO of Protein Industries Canada, Muriel, and also we'd like to invite some of our panelists from the morning. I believe Nesli and Elaine, they are still online. If we can have them as part of the panel too, that would be great. I think Dorit stepped out, so thanks. Dorit was like plus 9 hours, and same for Nesli too. So I would like to start with the question on how Canada is going to overall position itself in terms of all this global fermentation, bioengineering, cellular agricultural space. So are we going to be a partnership, or it'll be like a one-stop shop, more on the sales, business, technology, IP, or like raw material? So with that, I'd like to put Jay and Megan on the spot first, and then continue with additional additions from the panel. Jay, you want to take the first comment?
Sure. Yeah, thanks, Mehmet. I think we have so much potential in Canada as a whole, but I think that the world is globalization continues to be a thing, and I think that we have to be careful in the sense that innovation doesn't know any boundaries. So I think we have to look outside of Canada for the best innovation, the best ideas, the best people, and ultimately bring them here to build our own capacity internally. And when we build our capacity internally, it's also about collaboration. So what are the core competencies that we have, both regionally within different places throughout Canada, but also Canada as a whole? And then how do we leverage those core competencies with others around the world or other regions domestically to really provide a winning opportunity, both upstream and downstream, right? I think, Canada is very unique. If you look at right here in the prairies in specific, we have, a lot of unique biomass, which can work as very good feedstock, for certain types of fermentation. That will be very different from, maybe here, we can get into that, but, I think that's what we've got to think about, is how do we build winning collaborations that utilize each other's core competencies, both domestically and internationally.
Thank you, Jay. Megan?
Yeah, I agree with a lot of what Jay said there, that collaborating is going to be key to success, regardless of where you are in the world. Being open to working with the best technology, using the feedstocks that we have here, and figuring out, how we maximize the benefit to Canada, while still recognizing that a lot of the products that we're producing via fermentation are going to be consumed outside of our borders. And so there will be a lift for Canada in terms of developing technology, but also having the processing expertise and capacity here as well.
Thank you, Megan. Any other comments from the panel? Darren, Muriel?
Well, what we heard from companies, was that they were very concerned about IP, and so the whole idea of collaboration is challenging because of that, and so we have to overcome that particular issue in order to really advance collaboration.
Thank you. The next, I'd like to go to primarily on this discussion about the labeling, and there's been a lot of questions early on. We were asked about, like, can we talk about the GMO and the transgenic and the bioengineered products? What's the overall status? How do you see the overall the status of that? And I'd like to start with Dr. Corbett on this. Darren, if you'd like to see how the overall the status of this whole GMO and the positioning of the bioengineered products in terms of labeling and the market growth, and where is it going to fit in terms of that whole regulatory scope?
Yeah, thanks, Mehmet. Yeah, I think right now this is still an evolving area that the regulations, the regulatory bodies haven't yet have a clear picture about incorporating some of these ingredients in fermented products. It's, you know, in a general sense, there's no requirement. If you're just dealing with just fermented foods, I don't think that there's anything in particular there that's required. If you're using generally recognized as safe organisms as agents for the fermentation. But I mean, right now, I don't know if compared to other countries, I'd be curious to know whether or not there are labeling requirements in Israel, for example, or in Finland, with respect to, and coming from Europe, I think that would be more likely. But we've got so many GMO products right now that are in North America and Canada that are, you know, where we don't see any labels in terms of, you know, just regular commodities. That's pretty hard to avoid. So I know it's a vague answer. But right now, I'm not up to date with any specifics that are coming down the pipe there in terms of explicit requirement. So maybe somebody else has more information there.
The regulatory folks on PIC's team always, you know, work with our clients to make sure that they're thinking early and often about whether the process that they're using is going to trigger a novel food requirement. And so that's the lens, I guess, that we would work with clients in our program with, is understanding whether they're going to trigger a novel food requirement and starting that process early. And then labeling is the other piece of it. So, you know, what are you going to call your product, and are there requirements of things that you can or cannot say based on the process that you're using and the ingredients that are going into it. So that would be, I guess, the lens that we put on it from PIC.
I think
to follow up, go ahead, Jay. Thank you.
As I say, from GAP's perspective, we look at it from an investment, which regulatory obviously greatly can impact the return on investment based on the timeline that it takes to get to market and the revenue and the growth of that company. And I think it's really important that we separate in terms of regulatory GMO and gene editing and other things, because it's already been done. You know, in other industries, whether it's in crop protection or plant traits, you know, you look at now, Okanagan specialty fruits has been approved by the FDA as a non-branding mushroom. There's actually a GM salmon with Aqua Bounty. The UK has actually announced they're actually loosening their restrictions on gene editing. So when you talk about, and that's in Europe, right? So when you go from GM, like traditional GM, to some of the newer technologies like Cas9 gene editing or newer yet, there is both a difference and an expediting difference in the regulatory process, but also consumer perception. They've done a lot of work to show, you know, Mars, PepsiCo, they've done a lot of work to show that consumer perception on gene editing consumers are more open to gene edited products versus GM products. And I think that's started to influence the regulatory as well. So.
Thank you, Jay. Sorry, I was preparing a question for you. So I think I'll take it from here then. With your experience globally on the overall industrial fermentation and also now in the food side, are there any harmonized efforts in this whole regulatory scheme globally with different countries, from EFSA to like FDA or EPA or different groups globally? Have you had that type of experience, or is there any harmonization effort around this with the labeling regulations? And you can relate it to more on the industrial uses as well. If you can comment on that, that would be helpful.
Yeah, no, I think that's really important. So I think before touching on regions or globally, by sector, right? So if you look at the crop protection sector, where they've been doing a lot of work on, you know, either microbial biopesticides, you know, fertilizer, nutrients uptake, those kind of things, or biostimulants. You know, there's still, I'd say that even between Canada and the US, as far as the microbial biopesticide, The US can take 18 months registration with the EPA. It can take up to 4 or 6 years with the PMRA here in Canada. You go into Europe, it's completely different. There's in recent years, there's been some between EPA and the PMRA. It's getting better on how they share information and kind of not having to do completely 2 different data packages for that registration. But that's not the case with Europe. It's certainly not the case with Australia. Mexico is a little easier. And I think we've seen that on the other side, whether that be in the use of yeast for biofuel production and ethanol production, or whether it be on the food side, it seems to be that there's certain groups that are trying to corral and navigate, and it's getting a little bit better, but it's still very much a mixed bag, both by sector. I mean, even in animal health and nutrition, you look at probiotics and prebiotics for animal health. CFAA runs that here. You go into Europe, it's completely different, and the process is different. So it's very much the timeline and the cost is different by sector as well as by geography. And I'd say that there's not, you can take the same bacterial strain that's approved as a probiotic in animal health and nutrition. If you want to use that exact thing as a as a biostimulant in the plant growth, it's entirely different packages and registrations, even though the organism may be the same. So I think it's still a mixed bag. So
thank you. Thank you, Jay. Any other comments on the overall harmonization efforts? Megan, are there any efforts around Europe or other parts that you are aware of, just to combine the efforts globally?
Yeah, nothing that I can speak to in particular, Mehmet. I think it's like many of the topics that we work on, looking at international collaboration to make things, remove as many barriers as we can is an important initiative. And so definitely supportive.
Thank you. The next question is, I see Karen available now. I'd like to talk about some of this CRISPR technologies. We got some questions early on in the first section. Would technologies like CRISPR to be able to help the expression of the protein or other type of products with the microorganisms? Do you see that type of technology more being utilized in Canada and so through efforts with AgWest Bio? If you can comment on that. I think you're mute, Karen. So.
Well, CRISPR technology is just another form of gene editing, and certainly we work with collaboration is definitely the theme of all of our panelists, and we've seen, as Jay mentioned, more acceptance of gene editing tools than GMO. So that is an area that we will continue to say is a strength here in this ecosystem, and we can use to our benefit to promote what our capabilities in this space through the Global Institute for Food Security, the University of Saskatchewan. We definitely have a center of excellence in that type of tech.
And just to follow up, in terms of the training opportunities, like for scientists and technologists in the fermentation space, with our partnership with GIFS, AgWest Bio, everything, can you comment on some of the overall training opportunities and what we plan to do? Karen, from you, we'll go to Darren. If you can talk about some of the initiatives that what we are doing here in Saskatchewan.
Was that Karen first or me, Mehmet?
Oh, it's up to you. I think I wanted to start with Karen, but it's okay. So.
Okay. The training that AgWest is going to focus on is going to be specifically around training business management skills and entrepreneurs and helping them pathfind versus the technical training that we see as a huge gap in this industry. I mean, that type of training, there is a definite need for it too, and it's definitely going to help us be more successful in bringing innovation all the way through to a successful commercialization opportunity.
Thank you. Darren?
Yeah, and with respect to the on campus and in our department, we're really focusing on the technical side, hands-on as well as theory. Some of this would be provided in the form of like this webinar, basically, except an expanded sort of format where we will focus on specific types of sort of example food products that would be subjected to either submerged or solid state fermentation, and take people through the various sort of typical steps of the operation in terms of what to expect, how to, from all the way from preparation, planning and preparation through to the actual analyses and, dealing with products out the other end and trying to determine whether or not you achieved what you were seeking in terms of the objectives of the fermentation in the first place. As well as undergraduate, degrees of content that we've got in some of our courses that we provide to students in the undergraduate and graduate training options that we have on campus.
Thank you. With this one, I'd like to go to with Karen's comments on the business and the finance point, some of the functions and the growth that we like to start and achieve here with GAP and with AgWest Bio. Jay, if you can talk about how can GAP support the overall startups and these early startup companies, or at certain level, how can GAP help them to move forward in the overall their processes and businesses, and how can we assist with those type of companies here?
Yeah, thanks, Mehmet. So our focus on GAP is progressing innovation, which we believe takes years and not months. So there's certainly a good place in the ecosystem for incubators or accelerators where they focus on people and networking, and that's very valuable, and they offer 3 months, maybe some business development, business plan. But at GAP, we're very much focused on the innovation. So in the realm of fermentation, we actually have, we've got just under 14,000 square feet of laboratories and greenhouses. And in that facility, we also have the capability to go from high throughput screening, small scale fermentation discovery, all the way up to about 5 liters. And then we'll be working, as with others in the ecosystem, to go from beyond that to, such as in the Agri-Food Innovation Center, large scale toll manufacturing. So the aim there is that companies can come in, they can work with us at the discovery stage while still working with the greater ecosystem. So they're thinking about what needs to happen at scale. They're not working in kind of stage silos. And then in the meantime, they're reserving capital because it's, our lab's several $1 million to set that up. And we're able to kind of build that out, and companies can not only reserve their capital, not only progress rapidly and fail rapidly, but they learn from their mistakes and get up. And ultimately, it's about surrounding yourself with people, including ourselves, surrounding ourselves with people who are smarter than us in very specific areas, and that ultimately breeds success. Is our thesis. And then I guess I should top that with, we obviously making a meaningful investment anywhere from $500,000 to $1.5 million in the companies that we work with. So it gives them the resources to actually, give them some good runway to develop that innovation.
Thank you, Jay. Karen, any additions?
Well, I think that is also one of the strengths of this area, is that we have multiple partners that we can rely on for funding at different stages of your journey, whether it's PIC at that early R&D, proof of concept. Actually, PIC can probably help you in scale up as well. So we have them as a really practical partner. We have AgWest as something earlier in the pipeline before you're maybe still at proof of concept, and then you can move towards the GAP too. So there's a lot of different opportunities depending on what your company is looking for.
And just to add, I think one of those is the Global Institute of Food Security with their Opal platform. When we talk about the genomic sequencing and identification of specific genomes, is just a fundamental pillar in the ecosystem as we look at building this sector out as well.
Thank you.
Not to mention the food center itself, right?
Yeah. Absolutely.
I mean, Food Center will be helping the overall whole commercialization plans of all these fermented products. So with GAP, our partnerships with AgWest Bio, GAP, Ontariogenomics, and all the groups, Natural Products Canada, NRC, that we really like to help the startups and the companies to commercialize their plans on the fermented products, so that we can help them with the downstream in certain products, as well as utilize them and help them utilize their products in food applications as well. So the next question is, I'd like to go to Megan. Megan, would you like to talk about some of with the future, how you see it in terms of these fermented products and the fermented ingredients, with some of the supply chain issues we've been seeing over the last 2 to 3 years due to COVID, with all your interviews and the overall growth with the pig, how do you see the overall the growth for these products in Canada, and then how can we help with the products we have with the raw materials globally?
Sure, thanks, Mehmet. I think one of the key issues that we've seen as a challenge in scaling fermentation in Canada is talent. For a very long time, it's been hard to find folks who were interested in working in the fermentation space, had the background and skills and experience to really know how to, at scale, bring fermentation technology to market. So that was one of the reasons PIC was really excited to invest into this project with the Food Center and the rest of the consortia, is that we saw it as the beginning of a really great training opportunity. Another challenge has always been just capacity and facilities. And so the Food Center, I think, is the first step to bringing some R&D capacity and some initial scale up capacity. But when I look out, 5 years into the future, we need commercial scale facilities to exist where production runs can happen at scale. And so that, I think, is where we are headed. We're taking the first steps today, but there's still plenty of work to do in this path.
We have one question from India, Dr. Deepti. Just wanted to touch on that. Thanking all the presenters and organizers for all the informative webinar. With all these alternatives, which offer quite a bit of advantages in the future, overall asking about the strategies to overcome the cost for the production, the overall purity and the contamination of the products and storages, and is it possible to supply large in quantities and for the demand in the future? So like in certain areas, like can you comment on what's like from aquaculture going into much sophisticated levels of the different products, from feed to food, from food to like all the cellular ag? Can you comment on that a little bit, Megan? And then we'll continue with our other panel.
Yeah, so I think there's opportunities at multiple points on the value chain, right? So there's everything from that really complex, the cellular agriculture angle, through to creating ingredients with specialized functionality. So improving the functionality of a protein using fermentation, further down thinking of it as a food product or more of an entry-level sort of ingredient into a food process, and then not forgetting about bioindustrial applications as well. I think that's a really important aspect of this work too. So looking at some of the co-product streams we have coming out in large quantity from pulse processing or oilseed processing, and how do we convert those co-products into, a bioindustrial product that could have use outside of the food chain as well. Still looking at full use of that crop product that we're growing in Canada.
Any other comments from our panelists? And thank you very much. Thank you to Karen, to Muriel, Darren, Megan, and Jay, to all our participants, all our presenters. Thank you very much for all the participants. Again, thank you and have a great day. Thanks again for joining us.